Francisco, and today I'm going to present here our work about Honeypot. More or less, this is a continuous work, okay, with the previous presentation. The thing here is how we are going to learn from hackers before the hackers arrive to our robots, okay? Because so far, we have been involved in different approaches to face these cybersecurity problems in different fields, but we don't know what the hackers are going to do in our system. So first, a brief introduction. Here is just the usual presentation. When we have the robot in the industry, maybe at home, maybe in a healthcare center, we want to cover 5 main points. The first one is identify any possible issues or problems, then protect the system, detect these kind of problems, respond, and recover. Okay? The problem is that we don't know what is going to happen in our robots. So we need to move or to proceed with some steps before they arrive to our systems. For this, of course, the best solution is to make Honeypot. It means we are going to release some platforms working in the usual way, and we are trying to understand what is happening there when someone is interacting with the platform in the same way that the previous colleague do. So the proposal is deploying bait robots. Of course, we have several problems related with this, legal and privacy issues, but also how we are going to attract the hackers to our system. Okay? So this is overview in these 5 points and these 5 research questions, because we are trying to link more or less scientifically all the work that we are doing, and these are the implications that we do. The point here, I want to go directly to the main matter, is what kind of honeypotting are we going to deploy abroad? This is the main separation, the main kinds of honeypots that are available so far. This is based on the researcher, state of the art. And we can separate by field of operation, direction of interaction. Just to understand that server means passive honeypots, means that someone is going to enter, and client is that we are going to look for the clients. This is not our case. The clients, we mean the hackers.
Can you also quickly describe what a honeypot is?
Yes. What is a honeypot? A honeypot is a device that we release and is active in the same way that the real platform. This is in plain words. Okay? We are going to think that we are interacting with a real robot, but not. We are interacting with a platform that has the same behaviors, has the same characteristics, but we are trying to learn and get data from this honeypot. Okay? So in this case, when we talk about field of operation, when we talk about production honeypots, it's like ABB is releasing a robot, one of these honeypot robots, just to understand what the hackers want from their robots. Okay? Type by direction, by interaction level, we are going to describe, or we are trying to define which is the level of interaction with this robot. What it does mean? Usually when we release a robot in a healthcare center, we just put a robot there, like Pepper, and everyone is able to interact with it. You just need to open the head and connect a USB. And then we play in a new link. Okay? This is happening with several robots. This kind of honeypot is this high interaction honeypot means that you are going to release a robot, a fake robot of course, and they are going to think that they are interacting with a real robot. Okay? The medium, no. You are going to cut some of the features of this system, maybe from the robotic side, maybe from the system side. And the low interaction level, when we are talking about low interaction level robotics honeypotting, we are talking about these platforms that they are offering just services. So maybe an HTML web page that you connect and you move the robot. Okay? And finally, by the type of physicality, physical honeypots or virtual honeypots. In this case, we define both of them because we have access using different mechanisms to the networks, to the real robots, and so on. So what is happening here? Probably this picture is drawing better what we are talking here. We have the regular platform, the robotic service provider. So it's like in the same way that you arrive to any place and they are showing you, oh look, this is our arm, this is our software to control the robot. Okay, we're offering this. And then we have pure simulated robots, interfaces for interacting with real robots, of course, under our umbrella. So for instance, in this case we have a Tractable 3 example, but lately we are working also with RB1 from Robotics, a new layer on top of the robot to manage their interaction, and also using a Diablo. Okay? From Part Robotics, that we are trying to somehow hide some of the components to be able to launch in our platform. And finally, we have the third loop, that is the emulated robot. In this case, what you are going to find, if you find this platform, is previously recorded information from robotic sensors. And we hide some process in the system to make the attacker things that you are running in the real world. Okay? So this is a brief overview. These are the four options that we have. The fourth option is the service. It's like our colleague presented before, it's just an application with arrows, maybe a robot you are watching and you are managing. Okay. On top of this, of course, we need a monitoring system. For what? All the communication, all the data, like my colleague, for any kind of attacks, events, or intrusions that will be happening in the system. After that, of course, because this platform will be attacked, we need to offer a containment. In this case, we just release or we just diffuse or block any of the different components of the robot. So this is an overview of the platform, or the elements that we are just with handcraft scripting engaging, and our visualization tool that is based on state-of-the-art Grafana, okay, from other environments. So today, because more or less Honeypot is well known and so on, we want to show just one day of our platform release. The usual way, you just publish something in Twitter, you just made a mistake, maybe the password is there, maybe someone is trying to follow this link. It's so common. In this case, it's only one day. What we are watching here, some of the 6 logs of our system. We are just entering from our Honeypot some information. This is timestamp. Our machine, because we have not several, but some of them released abroad. And then the information, this is from system. The events that are happening in the system, like my colleague. But here, we have a jump before. That is what is happening on that system when someone is connected. Because this is a ROS-based solution, I forgot to tell you. We are just monitoring which kind of users are connected to the system, which is the paths that they are visiting, which are the commands. So here we can find the typical things and ifconfig, the usual. We need to set up the environment for ROS, and then after setting up everything, we will find here some commands, rostopic list, rostopic echo, different commands of what is happening there. Okay? If they are not writing anything, we have like there, we are anyway getting all the data. Okay? Because what we are trying to do with this is to learn what they usually do with our platforms before they do with the real platform. Then we just check a little bit the networking. Okay, this is the typical who is IP. Okay, these are our messages. These are the countries from our messages are coming right now, and we compare with our other servers. More or less, at this point, is the same. They are similar. Okay, from Europe, mainly from Europe, Madrid, is because we are in the same network, connecting different colleagues, generating regular traffic, and the other one are unknown messages. What was strange for us is that from US we have several messages. So we just decided to go a little bit further, just to understand which are the networks, the owners of the networks that are facing our honeypots. Okay? From here, because we have different layers of network analysis that I'm not going to talk here, is for instance the flow. Here we just discovered that some of our attackers or visitors saying hello are coming from VPNs, different VPS. It means secure networks, they just ping or brute force attacks. Okay, this is just I think was half an hour. Okay, just some tweeters. Of course, so far in this case, what's the problem? Apparently it was just a regular command from one colleague or something telling Twitter, oh, I want to test it. So we didn't find anything strange in the log side, but at the same time we found different messages, different signals from the network side, just to keep in mind. So from this short experience and some feedback from our users of the platform to understand if we are easily fingerprinted, that is the worst case scenario. What it does mean? It means that someone is connected to our platform and is telling, okay, I am in this platform, but now I know that this is a honeypot. So I should not be able to hack this platform because probably they are taking care of what they are doing now. So we just asked so far 4 or 5 users what are their experience with the platform, if they found something different with the real platform. This is just with Tartabo 3, sorry. And we are trying to do the same with Thiago and RB1. Just our biggest problem here is here, from the creation. It means that they are using our platform to jump to another machine. Okay? So far, these are our brief discoveries. Apparently, it's people just, oh, I want to test, and then I'm going to open the email, I'm going to send some messages, I'm going to, it's a stage. So we need to release and give more time, of course. So the conclusions with this is that honeypotting should be starting spreading abroad because it's necessary before to release robots in the real world. Because so far we are finding a lot of robotics in supermarkets, healthcare centers, and it seems like everything is perfect, and not. In our case, the solution that we are implementing right now is a framework platform independent. So the migrations between, for instance, from Tartabo to RB1 was more or less straightforward. Now with Thiago, we are more or less ready. We have also physical networks on the loop. It means that our honeypot is based on real networks. We have different devices, I mean the real robot in a real network. So we are able not only to do honeypot in the system, but also honeynets. That in systems like ROS, Robot Operative System, that is one of the platforms more aesthetic. I think that this concept is clear for everyone. Is the most important thing. It was in ROS 1, it was the TCP ROS and UDP ROS, everything in plain text, a big hole there, and now we need to face the DDS and which are the future of these communications. Of course, the cons is that some of the roboticists that are interacting with us discovering easily that they are in a honeypot because some of the hardware components are not there, of course, because are limited. Okay? that's all. This is our future work, is what is the cognitive side of a robotic platform. We are watching here just the technical side. In the future, we want to face what is happening if someone asks for an order. I mean, he's asking a robot, please put a beer to this kid or something like that. This is the cognitive side, and we need to face also the cognitive. There are other works right now in the state of the art. And then, like we always say, is the legal issue related with the platform. And that's all. Thank you for your time. Any question?
Now we have time for 1 or 2 questions. Anybody's up to it?
Yes?
You mentioned several times, I see that you can hear me.
Yes.
You mentioned several times Java.
Yes.
What's the main problem that you found in Java?
The network configuration that it has by default. Because when we assemble the networks, we need to make some VLANs, virtual LANs for us, just for getting the data and for the coordinates. Okay? If we remove this part, it's quite straightforward. But we want to be sure that we are going to be able to make it. So this was the main reason. So it's more or less straightforward. I mean, it was done, but we wanted to cover all the possibilities of nodes in our system.
We have time for an extra one.
Yes.
Thank you for your presentation. I really liked the fact that you used LaTeX for your slides. The question is, have you tried all of this in a real world scenario and in terms of acceptance of the companies who should, in the end, implement this solution? Because it seems for me, like really from a very, very high point of view, that you need a lot of effort for implementing like a parallel infrastructure, being virtual or physical. But in the end, it must be somehow efficient for the end user.
Yes. So far, our idea, for this reason, we